Good morning, everyone. Welcome to this talk about keeping up with rapidly evolving technology in architecture, engineering, and construction industry. A Canadian context. My name is Sam Exeson. I want to thank KMEA College and Beam Cafe for giving me this opportunity to present some of the works we do in Canada using the latest technologies. We will be primarily talking about BIM and LiDAR scanning and how we use these two technologies in a small office of ours in Canada to provide the need that we have in that industry and lack of resources that we have. So I'll start by speaking a little bit about myself, the presenter. My name is Sam. I studied in Satyabama, Chennai. I'm from 2005-10 batch. Then I moved to Toronto in 2015, where I studied a program called iPlan at Ryerson University, where we focused mostly on BIM, the materials and construction methods of Canada, and the Ontario Building Code. That's where I was exposed to BIM, and from there on, I've been working only on BIM for the last 10 years. I've been in the industry for the last 15 years, and in 2010, I started a company called Digital Twin, where we focus on LiDAR scanning and creating BIM model out of point cloud data. I currently have a studio in Cochin, and we do a couple of small projects here in Kerala. I'm also working at C-Space Architects as a designer and a BIM lead there. So the office is in Bolton. When I joined the office, we were just a team of 3 people, and now we have grown to a size of about 10 people, 3 of them working here in Kerala, in India, and 5 of us back in Canada. I just want to give a couple of credits about this talk here. Heavily I've relied on a talk called BIM for Project Managers from Ralph Montague from ArcDocs. So if you search for BIM for Project Managers Ralph Montague on YouTube, you should be able to come across this video where he talks about BIM and how about the BIM standards and why it's important that project managers adopt BIM in their workplace. I highly recommend that you watch that video. It'll give you a huge insights into what is BIM and why we should adopt it. C-Space Architecture, which is a firm I'm working with, many of the projects I'm presenting today are from C-Space Architects. So let's start with building information modeling. And I just want to start with why building information modeling and what is building information modeling. So building information modeling comes under the information and communication technology. So it's important to understand that BIM is not just a product, but it's also a process. It's a process which is standardized under ISO standardization. So if you search for ISO 19650, that's the information management using BIM. So it's published in 2018. So we are quite new to this process of information. And why is it important? So the primary goal we need to have in any project is to manage expectations of the client. Not just that, we have to identify, understand, and resolve issues during planning and construction. Also, we have to analyze risks, opportunities that are in construction, and effectively communicate that with the clients, so that we don't have any delays and we can have decisions done on a timely basis. So these are key points you want to have in a well-run project. So And above that, there are challenges in construction industry itself. We know that the buildings are way too expensive. It takes way longer time to build these days. The performance of the buildings are not that great, and the quality that we aspire for, many times we are not able to achieve that. So in a larger scale, we are trying to address that issues too. So building information modeling is an answer to many of those questions and many of the challenges we have currently have in the industry. This is Toronto. This is where I work, and I lived here for like almost 5 years before moving to one of the suburbs of Toronto. So what you see here is the built environment. So that's a B in building information modeling, the built environment. So you have the buildings, not just the buildings, you have the roads, the infrastructure. So it is important for a well-run city to have good infrastructure behind it. I know many of us from India, we wish to go outside and have our lives outside because of the lack of infrastructure that we have in our own cities. So it is important that we have a good built environment to have a good quality of life. So building a good infrastructure and a city is always very important. You go to the street level in Toronto, this is what you see. There's always construction going on. It's either you have these high rises providing more housing for whoever it is needed, or like even the public spaces that is required. So always building is going on. Behind every built environment, what you don't see is a huge amount of information exchanged. So from the beginning, when you're applying to build for a building, or during construction when you're exchanging information between architects, contractors, the clients, and different consultants who are involved in this project, there's always information getting exchanged. On the left side, what I'm showing is the process of just getting this is for official plan amendment. So it's a small portion of getting the bylaw amended to build your own building. So this is a tiny part of the overall process of getting a permit for a building, but you can see the amount of communication that is involved in getting this. So what ends up happening is that you are exchanging a ton of information, mostly through paper format or a PDF format. So you can broadly classify people who are involved in building a building into and maintaining a building, not just building, but maintaining a building into 4 categories: people who own it, the people who design it, the people who build it, and runs it. And often these are not a single party. There are many stakeholders that are involved. So from who owns it, it's client, it could be client, or it's a private client or a public infrastructure project. And then there is regulatory authority is always representing the public. There is nothing ultimately fully private. The society has a say in what you're building, because it's important that we build with quality and represents a good health and safety standards, which because the public has to rely on and eventually has to come into your property, and it is important that we build appropriately. So the public always has a say in it. So regulatory authorities comes in. Those who design it, the architects, civil engineers, and structural engineers, and mechanical engineers are involved, and the building people who build it, the general contractors, subcontractors, and the trades, and who runs it. So if it's a hotel, the owner would be somebody, but the one who runs it might be Hilton or any other kind of management company. So traditionally, the way we coordinate with each other and come to decisions is through describing the building and the processes, right? So you're trying to describe how you build it and what you're going to build it through drawings, and you're going to communicate with contractors by describing how the details should be done for the particular building, and you're going to describe to the procurement team what all has to be procured using schedules, and then there's specifications and the project management documents to communicate between parties during construction, and then there you have the operation manuals for those who are running in the building in the future. So you can see in a traditional method, we heavily rely on paper and PDF methods to go back and forth. And this becomes very cumbersome for large scale projects, and even small projects. Eventually what happens is that all these documents get shelved under a under a folder somewhere deep inside the computer, or like in a basement somewhere if it's paper document. And to go through a certain detail, you have to search for a certain detail or find the specific information. It becomes very difficult. And we have come across these issues in multiple times because we do a lot of renovation projects in Canada. And to find an as-built drawing set, it's so difficult. You have to go through many rolls of sheets. We are not sure how many times the renovations has done. We are not sure. Is this an accurate information? So it becomes very difficult. So the idea came about, how about we build a virtual building, all right? So that's the building information modeling part of building information modeling, BIM. So why don't we build a virtual building just like we build in real world, but inside a computer, and the people who own it, the designers are the one who is in charge of building this thing, and those who owns it, builds it, and runs it have access to this virtual building. So during coordination and during design decisions, all of us are involved in creating this virtual model. And then from that virtual model, we can extract drawings, details, schedules, and specifications, project management documents, and operations details. So it's a completely upside approach of what we traditionally do. In traditional buildings, we are describing a building using this partial information, but in this case, we are virtually building the building and then extracting this data out of this model. So it's not really modeling. Suddenly when you say BIM is modeling, people would have a wrong idea of BIM itself, especially those who are not familiar with the process. They'll say, okay, if it's modeling, there are other tools which are available in the market. Let's say there is SketchUp, 3ds Max, multiple kinds of software, even Autodesk Fusion to an extent, which can be used to model things. Why do we need Revit? Why do we need something this expensive if it's about modeling? So that's where I think we should see this slightly differently, because it's not about modeling, it's more about managing the information that we have. All this paper information and PDF information that we had, we are trying to avoid that and move to a virtual building where everybody can access this information readily, search through it, query what we need to see, and understand the operations of this facility on a long term. Not just querying and getting the information out of it, what we can do is we can add geolocations to these virtual models, weather data, and then analyze and optimize the building itself. So, for example, if you have the geolocation, you can actually bring in the solar exposure to a certain face of the building and figure out if we provide more horizontal fins, or if it's a north facade, if you provide more insulation, can we make this building more energy efficient? And then optimize it, and then rework the building before it's ever getting built. And point cloud data, which we will speak about in a bit, that allows you to bring the environment itself to a great detail. And especially if you think about in a city context, or like a small interior space, let's say if it's a small interior space, you can bring all the data that is required and then start this virtual model from the most accurate data that's possible. You can also sequence the construction phases using tools like Navisworks to really project management. Navisworks also is used for class detection between different disciplines, let's say architecture and engineering versus electrical and mechanical. So you can just see when different people are creating these virtual models, and you can bring all of them together in one location and then understand what are the difficulties you're going to face in the real world while constructing the building. You can bring the cost element to it, so that will again add more complexity to this virtual model. You're trying to be as real as possible and then analyze it, optimize it. And then you extract the data, what is required to help you build this building. So the first point I want to make is BIM is not about information, not about modeling. So we have to get that idea off our head. It's not about modeling, it's about information. And with the latest tools and plugins, you can bring a lot more information, right? We can stress test the building if you have plugins which are used in structural engineering. You can analyze the energy use of that particular building. And there are tools like Dynamo, which helps you visually program certain aspects of the building. You can query certain data, so you can check the information what you have done is correct or not. You can do parametric designs with these tools. So it's all about information, the underlying information behind it, not what you see as walls and floors and structural elements. It's not about modeling. Second point I want to make is building twice is always better than once. So that's what BIM brings to the table. A good comparison to this is like what's happening in the manufacturing industry. You could broadly classify the operations, what is happening there in design, procurement, construction, and operations. So these are four stages you would have in a manufacturing industry. For example, if it's a car, first thing you do is like you create the whole model in a virtual environment. And from that virtual environment, you can extract the data which is required to procure all the necessary parts that is required for that particular production of car. And then you go into construction, and then once it comes to the track on the road, you have a lot of data coming back from the users and the engineers who are testing this product, and then you plug it back to the manufacturing. And there's a certain sense it's good that architecture is not like manufacturing, because then you would find is like this boring, repetitive building, like cookie cutter housing, what you have in most of North America and Europe, right? So there they have made the process so efficient that making any changes would be so difficult. In architecture, it's not the case, but there is so many good things you can actually learn from manufacturing industry. So you compare that manufacturing process with building construction. The design and procurement stages always happen in a traditional way using these paper methods again. You have some models, some CADs, which will help you to do this, but ultimately you narrow it down to a couple of some documents which can be printed out, sent as PDF, and then you go into construction and you face a lot of these problems, which these paper documents and PDFs are not enough to deal with the problems what you face. You go into operation phase and we never learn anything out of it. But when you're introducing BIM, what you can do is that you can do this virtual building in the design stage itself. You can rely on the manufacturers to give us the information that are available in the market, bring into that virtual model. So the procurement kind of happens while you're designing itself. You can call the manufacturing companies and figure out what are the lead times for certain products. And then once you go into construction, you're still collecting data from construction and plugging back into this virtual model. And comes down to the operation, you're still connected to that virtual model. So in a certain way, even if it's more linear process, we can still learn and benefit from the construction site, the operations, and update this building information model or management program to give us more insight into the built environment. So that's the second point I want to make. The third point is buildings have a long life. So as you can see in this graphic, the design and build is done, but then you operate for like 50, 100 years. So that's a long life that a building has. And if you can learn and get more data during the operation of the building. For example, the energy efficiency of it, how much cost the building incurs in its lifetime by doing maintenance of a particular area. Let's say, is a pavement outside, or is it because of the design decisions what we made, there are certain areas are more crowded than the other spaces. Certain corridors are not really usable because it's just like buried deep inside the building somewhere, which could have been used for another purpose. So all this information can be, I mean, there's no way of understanding now, right? Nobody's operating it, but like with the Internet of Things, where you have these small equipments which can be connected to the internet, and you can just get live data out of it. So there are virtual models that are created and maintained on cloud, where you can constantly learn from the operations, and that can be used for the maintenance of a building in a long term. So you can see the clear difference and the winner between these traditional way of like having a basement full of paper versus having a live model which constantly gives you data to maintain this thing. So buildings have a long life. And the third point is pseudo BIM. So this is again a coin. This is a term coined by Ralph Montague in his talk, where he talks about we still traditionally there are still a lot of offices design and construct using the traditional methods, which is paper based, and just in addition they have this Revit model going on the side parallel, right? Which are just used for like taking 3D renderings, and so you're not using the all the points I made earlier, which you are not using all the information that is available. You're not building it twice, and what it ends up happening is that you still have the same issues during construction because you're trying to figure out things on the fly, and it incurs more cost and time delays your project and so on. So pseudo-BIM is a waste of money. So if anything you're taking out of this talk, it's these 4 points. BIM is it's about information, not about modeling. Building twice is better than once. Buildings have a long life, and pseudo-BIM is a waste of time and money. For those who want to understand what a BIM file looks like, so this is a project that we have done in Canada, which is in Bradford, West Gwillimbury. So this is an old school which has not been used for a long time. So it's quite in a dilapidated state, and the city wanted to convert that into a community hub where it would provide more use for the neighborhood. So they would have like a food bank component to it. There are spaces where you can rent out and run your operations, or like small offices there. So we were tasked with this with this project to convert this old space into a renovated space. So this is what a building information model look like. So instead of just a drawing, what you have is the existing building completely modeled in Revit. And when client asks for, okay, what can we see what it's going to look like in the future when it's built, so we have this completely modeled, renovated model, so the client has a clear idea of what he is getting. So you can see the difference between the existing model and the new model. A couple of notable changes. What you have is this removal of this small portion you can see on this side, and then we have added a new auditorium space and a kitchen inside, so that it can be used as a community space for the neighborhood. This is a slice through the building, so it's like the plan view. Instead of just having lines, what you see generally in a drawing, this is completely modeled. So each and every door, every room, every wall has its own information embedded into it. So as a contractor or a client, Um, while this model is on cloud, you can click on it and it'll say exactly what that particular what the make of that particular wall is. So if it's a partition wall, it would have steel studs in between or wood studs in between with gypsum board on both sides. Based on the STC rating required for each room, so you would have insulations inside. If it's a fire rated room, that would be made out of block wall. All this information is right there in this model itself. The doors would have the fire rating requirements, the manufacturer. If it needs electric strike, that would be um, that could be easily identified. Which doors have it identified from this model itself. So this is the existing model. Here's the renovated model. It's complete with furnitures and fixtures. You can see even the landscape is done with the a nice um, food garden outside, just outside the food bank section there. A little bit of zoomed in view so you can see the kitchen view. All these equipments were downloaded from the manufacturer itself. So when these models, for example, this is a soup kettle we brought in from common market, which is called BIM objects. So where the manufacturer itself posts their products in terms of this virtual product. Once you download that, you know the power information that is required to plug this device in, to operate this particular device. What are the plumbing requirements? Where do you need the drains for this particular unit? And all those information is available. These are the washrooms. So again, you can see the difference between the block wall that is in the middle and then this partition wall on the side. So it's clearly identifiable just from the 3D itself. And from there, we extract the data, we create drawings out of it so that the contractors have all the needed information to build that particular washroom. This is the existing building photograph of it. During construction, you can see how complex the construction is in Canada. You have multiple materials used in the same construction site. So you have the concrete base, steel columns and steel structure, steel joists, steel deck, and then you have certain portions having steel studs kind of framing the skylight openings and such. You have wood studs framing the office spaces. What you see here in green is spray foam insulation to provide airtight sealing between these transitions. During construction, and you can see that in the exterior, in Canada we do use plywood or OSB to cover up the structure, and then you would have like a membrane stuck onto it for waterproofing. Then you have the insulation on top of that, and then what you have is aluminum panel over it. So it's like a rain screen technique. So this is a completed building. You can see it, we have uh, renovated to be very useful for that neighborhood. So you know they have a community space, they have a business space, and people are quite happy with it. This is the photographs during the inauguration of that particular thing. So you have to understand this complete project is done by very few people in our office. So in a traditional office, it will take like 4 or 5 people to kind of completely go through the paper documentation that is required for it. But in our case, it's just a team of 3 or like less than 3 people, including the main principal office person. So I was on site multiple times, scanning the information and getting all the details that is required. Creating the model is completely done by one person, and we were able to do it in a very short period of time. So I'll show a couple of projects where we have used LiDAR scanning and point cloud data. So first we'll talk about what is LiDAR scanning and point cloud information. So the scanning part, the equipment, um, the scanning equipment, that technology what uses is called LiDAR. So to easily understand it, that imagine you would have seen one of those laser measuring tapes which people use to measure height. So it has a pulse of laser going, and the equipment measures how long did it take for that pulse of light to return to the source, and then you have the length from the time that it took for that return signal. So imagine that laser measuring tape spins on a tripod 360 degree while rotating 360. So what ends up happening is that it collects all the information, all the distant information in its surrounding, in its point of view, and then plots it on an XYZ axis. So that's called point cloud data. So what LiDAR scanners scan is using is using laser technology, and then once it plots the data, it's called point cloud. So you can see a donut, which is a point cloud. So that's basic, just to give you a basic understanding of what point cloud data looks like. Now, how does it look on a architectural scale or like architectural context? So this particular image is my house in Toronto, in Brampton. So it's close to Toronto. You can see the extent of that scan. So this took about like 20 scans, but you can see I can get the road. So that's the David Street, the setbacks to the walkway, the front yard, the main house itself, and the mudroom that is attached to the house, the pergola, the garage, and the overall length, rear setback, front setbacks. All this information was available from just one single scan. Not just that, you can have the plan information. On section, you can see the height of the silver maple tree which was there, the dia of the canopy, um, and the trunk itself. So much information is available from just one single scan. So you can see, you can imagine if we can bring this data into a building information model, you can avoid a lot of doubts and confusions that you have about site, and knowledge that you have about site. This is a sections through the house itself. So the data is so dense that you can zoom in to a micro level from a macro level, and then let's say it's a stair depth or the stair thread you're trying to measure. All this information is available from just one collection of point cloud data. You can see how accurately you can measure all the heights, the slope of the roof, um, and you know you can see the basement extending down the grade. All this information is available from a point cloud data. This is a section through the plan. Another section, if you go to my website www.digital-twin.ca, you can see some of these point clouds. This is another point cloud data we have collected from a church in Toronto, Willowdale Baptist Church. So you can see it has an auditorium which seats about 300 and 350 people, and other additional rooms. And there is no other technology that is currently available which lets you see buildings in this detail. Not just that, you can see the exterior in relation to the interiors, and especially the basement. So it's almost like bringing a CT scanner to a building site and doing it. But the difference is this is a much smaller device which you can actually move around, take the measurements, and gives you this data. This is a very interesting graphic. You have on the left side the original building, which was built in 1950, and then you have an addition which is done in 1920. So one of the small projects that we've done. So I think it's important that we understand this is not just for large scale projects. We can use this technology, both BIM and point cloud, for smaller projects. So this is Havergal College, and we were tasked to do a small security desk at this college. You can see it's a prestigious college where you have a lot of history and character to that space. So first thing we did is like we scanned the whole area, collected all the data that is what is required. You can see the security desk at the corner there. It was not sufficient for the current use. They had a lot more security cameras these days. So they wanted a larger space to uh, a larger space to accommodate their needs. So just to give you a bit of context, not just the reception itself, we did scan a portion of other sites as well, just so that we have a relation to other spaces when we are presenting to the client what we are proposing. That's a view of the security desk itself. So the what client was asking is that, okay, can we bring that security desk um, kind of snugly fit between these two columns so that we have a larger security office inside along with the desk. So since we had the point cloud data, what we did is like we immediately went into conceptualizing what we want to build. Um, in comparison to if you had just the data measured from a tape or whatever, we have to start drafting it, kind of assume what are the other details. In this case, we have all the details that is required. We presented a couple of options to the client, some challenges you would have having large monitors just in front of you, which will block the sight lines to whoever is coming in, so you can't monitor people coming in and going out of this particular area. Possible solutions. And when it comes to the design itself, because we had this point cloud data, we could project the ceiling and see, what kind of details were there on that beautiful vaulted ribbed ceiling. And what we came up with is, okay, what if we can borrow that triangular detail, that profile that you have on the ceiling, and create something with it. So from that idea, we just folded a sheet of paper and we said, okay, what if we just have this folded pattern for the desk itself? It goes with the beautiful ceiling you have there, and also it's still modern, right? Just gives you a perspective of what the school is trying to do, what is the university is trying to do. It's modernizing it without removing itself from that cultural heritage that it has. From there, we just went to production of drawings. You can see we are still using point cloud data to present our drawings, and all these drawings were produced. You can see the security screens kind of lined up there. We have all the information that is required to go into production. And this is our factory visit. You can see the panels being made. The desk itself was laid out on to see the scale of it. And this is installation on site. You can see it coming out beautifully with this oak panel finish. The important thing here is that, again, we don't have too much resources in our office, so just one person can do it. In this case, I did the whole project. So went to the site, collected the measurements using point cloud data, designed it, did this small paper model, presented to the client, went to the site, coordinated with the manufacturers, and then executed on site. So, with very little resources and with a very narrow timeline, right? We had just a window of like 3 or 4 weeks when the college was closed to kind of execute this thing. So you can see how useful building information technology and point cloud is useful even for a small desk like this, right? This is a slightly bigger project, a much bigger project, obviously. So this is Shoal Stone. It's a head office for Shoal Stone. They produce stone cladding and other materials for building construction in Shallow Lake, Canada. Um, they are one of the major suppliers for many of the public buildings. Also in Canada, for example, Windsor City Hall, they provided the um, brick and stone that is required to clad that building. So very um, you know old factory, but they have a rich tradition in that area. So they wanted to bring their clients into a lot, into their um, production facility. So they wanted to give them that experience of, look, when you're walking in to see our products, it's not just the product you're seeing, but also you can see the factory which is behind it. So this warehouse was there. So the idea of the client was that, what if we can just retrofit this to have to house our office. Again, the first thing we did is, like, we just went and collected the point cloud data that is required, and then we started with simple sketches. So you can see it's like childlike sketches, right? But we are not shy to present this to the client, because we have done our homework, we have collected all the data. We don't have that insecurity to kind of go with like fancy sketches and fancy presentation in the beginning itself. So the client knows we are doing our work. Couple of small bare bone sketches to present our ideas and see if the client likes that, is he leaning towards a different model or a different idea. um, and then again, immediately we went to production of building information modeling. So we have all the data that is required. The client likes a certain idea, then what we are showing to the client is immediately, this is what you're going to get. So there's no confusion. He's not trying to guesswork from a couple of plans and sections and elevation what he's getting. He can actually walk through this building, see in a virtual model before it is ever getting built. The contractor is happy because he knows his scope of work, what he is doing and what he is not doing. There is no much confusion. Not just architects, but structural engineers, mechanical engineers. If everybody is using building information modeling, you can avoid a lot of difficulties at site. So this is the elevation. Again, it's all from Revit itself, and we use Enscape to render all these things. We have drawings produced out of this building information modeling. The client would like, client like to try out different textures, how it would look on the building. So within a couple of days, we were able to provide the renderings, how would it look. He was happy with it. And then interiors to lighting. So this is a complete building. You can see it came very nice with that large canopy inviting us in to go and see the products which are displayed inside. Beautiful polished concrete floors, white interiors. Especially in Canada, we have long winters and the sunlight is quite scarce there. So we wanted to make that space looks quite lit up. So the interiors was done by a firm called Mayhew Interiors in Canada. So we did the exterior, and the structure was done by Pinpoint Engineering. So we do have close collaborations with Pinpoint Engineering for many of the projects. We also do landscape design using Point Cloud. So you can see this particular site. They were asking us to do make that exterior landscape more inviting. So because we had the Point Cloud data, immediately went into production. We model everything so the client can clearly see. So we are virtually made the landscape. So the BIM and Revit can be used for landscape design as well. This is the top view, and this is the landscape that we have proposed. Quite organic path, so that you don't have like direct, like you're not like in let's say in an army where you're directly running towards the door in an emergency situation. You have this meandric path around that building, so you can casually stroll through after you parked your car and come into the building. Because we have the point cloud data, we spend less time on modeling because we are not guessworking. We are not trying to correct the model over and over again to make it look good. We know exactly where things are. So that gives us ample time to go back and focus more on the design aspect of things. This is the last project I want to share. This is not in Canada, but this is in Calicut. So point cloud can be used for historical preservation as well. So this particular building is quite old. It's 175 years old. The construction started in 1842, and it was opened in 1956. So what we did is we collaborated with a firm called X equal 2 from Calicut, and then we did the point cloud scan of that church so that it could be used for teaching purposes, also as a historic preservation. You can see there's a section through the interiors. This is a church organ which was gifted to this church from Cheltenham, England. It was placed inside the building in 2004. Beautiful, beautiful church organ. So you can see the details. This is a plan view of the site plan view of that point cloud. Again, like I said before, we can slice through the building, seeing thickness. So it's built on 10 pillars, 5 on this side, 5 on the other side, and then it's beautiful arched galleries on both sides, 2 balconies on top, and this is the bell room. So this is cut on an upper level, so you can see where it's cut. Sections were cut. So what we are trying to do, so just to give you a amount of detail, right? So this is from a macro scale, you can see the whole site and section and everything. On a micro scale, this is a podium in the church, and this is a portion of this detail. You can see it's 10 centimeters, and see how the amount of detail in that small area. It's thousands and thousands of points, so you can get very precise measurements from this point cloud. So what we're trying to do is like not just scan this building, but create a virtual model of this particular church. So you can see the BIM model of it. 2 of my colleagues from Digital Twin is working on it, Tushar and Anina. So they are working on creating the digital twin of this thing. Here's the front elevation. You can see the model in elevation, side elevations. So ultimately, I just want to close with this particular question. What do clients want? So one thing you can say is that clients don't want you to use BIM or Revit. They're not going to specify what you want to use. Do they care? Mostly not. So what do they think? Like, what do they want? So again, I'm going to quote Ralph Montague. For most clients, building a building would be one of the worst things they would do because, it's not like buying a car or buying a phone. You're not getting what you wanted on time, on the money that you promised initially. There's always a risk of, not, confusion on scope, what you want, what you want to build, confusion on the timeline because things get delayed because of issues at site, properly not coordinated drawings, delays in procurement, and you're not getting the quality that you wanted because of all these issues. What is happening at site, eventually projects get delayed and the quality suffers. So ultimately what the client wants is value for money and time certainty. He wants to know what he's going to get for the money he has paid and in the time he was promised. Everything else is secondary, including the look of the building. So that's why you can see most especially in India, most buildings you see is not particularly follow a certain style, or it's very utilitarian because ultimately people spend a lifetime of their savings to build a house back, here in India, and what they almost always look for is value for money, and to get that built on times, which doesn't cost him again more money. So the scope is important, the time is important, the cost is important, and based on three things, the quality is dependent heavily on these 3 things. So using BIM, you can using 3D BIM, you can show the client what the scope, the complete scope, what he's getting. Using 4D BIM, you can sequence how things are going to get built and the timeline of when you can expect a certain task to be completed and the rest to be started, and so that way we can organize the requirements and what things has to be done in that certain way. 5D BIM, you get the cost information included in the model itself, so you know exactly when you're making a small change how much it's going to cost you in terms of both time delay and the cost overrun. The current way of doing things, where we are using paper and PDFs, you make a small change, you have no idea how it's going to impact down the lane, right? Often what happens is the client come to the site and then start changing this, that, and even the architect is not able to explain to them what is going to cost in the future if you make these changes now. But in a virtual model, you can always go back to your office, make those changes, and say, okay, if you do that, these are the impacts that's going to happen. And that way, again, we are bringing back, that what the client wants, which is a complete understanding of the scope, the time, and the cost. Now, this talk which I'm doing in KME is for teachers. So, I how can you invite students into this process? So when the students are designing a building, you can ask three fundamental questions what a client would eventually ask to that student, and there's no way of doing that easily within the time frame that they have to give these answers if they are using the traditional way of designing things. So that's a good, let's say, a motivation for architecture students and civil engineering students to start using BIM, because you can give answers to these fundamental questions. Can I see what I'm getting? Right? Not a portion of it, not a description of it, but can I see in 3D what I'm getting? Right? So the BIM helps you visualize those details, those spaces. How long would it take? You can use tools to kind of sequence the construction and say that, look, it'll take this long to completely do this building, and we know it because we have the quantities, we know how long would it take to build these certain details, and we can timeline it properly. How much would it cost? Again, we have schedules, quantity information, bill of quantities. You can call up the local contractors and subcontractors and talk to them. Look, I have this much quantity of concrete I needed. How long would it take to build this much square feet of floor? And then that way, while while studying itself, they have a proper understanding of how to build a building. I hope this talk have been productive, and I just want to conclude with a building that I've built recently. So this is for my family. So this is built. This is my parents' house. So I have two brothers. So we all pitched in money, and along with my father, we built this house. And someone who is involved in this technology, I used all the tools that is available on the trade to build this building. So some images of the interiors of the building. You can see I've used point cloud to not just measure the site, but to figure out whether the construction is going as per the plan, or are there changes, tolerances, differences. When the concrete is built, I just wanted to make sure that everything is lined up properly, and if there is small differences, I wanted to make sure that when I'm doing the millwork drawings, it's reflected on that drawings to avoid misfits, mismatches, and all those things. You can see the BIM model on this side, so you can see the similarities between it. We haven't changed anything before construction. Before construction dolls, BIM model was done, and thereafter nothing was changed. So because of that, no cost overruns. We were able to manage. There were expected cost overruns because in the beginning itself, I knew that if a project lasts for like a year and a half, you can expect like 10 to 15% of increase in project budget. But that was very much expected. And anywhere we have spent extra, we made sure that we cut on something else, and we made sure that it was built and finished on time. So with that, I'm going to conclude my talk. If you have any questions, you can comment below, and I'll be happy to answer. Thank you very much.